Hi, everybody. My name is Tiffany Sargent, and I am the Director of IoT, and I'm also the Chief IoT Architect for Public Sector Americas. And I look forward to sharing a lot of exciting information about how to do architectures in the public sector. So as we move forward, what I'm going to share today has a lot to do with what we've learned across Intel Corporation in IT for the past 30 years. So a lot of people are thinking IoT, that's something that we've had most recently in terms of a technology vector. And in fact, we've been working on IoT at Intel Corporation and in general, the field, for over 30 years. So when we think about IoT, we think about it in a couple ways. You think about it as cyber physical systems, and we think about it as embedded products. And we think about embedded products as anything that might be in a non-client or non-server architecture. So when you think of machines, or you think of airplanes, or you might think of something in terms of a health product, you think about IoT and embedded products similar to how you think of industrial controls and cyber physical systems. And so the reason that I wanted to bring this up is although we have been using the word IoT for a short period of time, we have been working in IoT for a long period of time. So when we think about IoT, we think about it in terms of enabling people, devices, and systems, and how we turn data into information that delivers value. So when I talk about IoT in the public sector, when I use the word public sector, I'm using it in two specific veins. The first one is around national and federal government, and the second one is around state, local government, and education. And the reason that I'm talking to you today about public sector IoT is that when we develop public sector IoT, there are some unique attributes to doing public sector work that are above and beyond commercial IoT work. So I'm going to take you through a building block approach so that when you leave my talk today, you'll be able to have a better understanding about how to architect as a developer, how to architect as a business leader, an IoT program in the public sector. So I'm going to go through a building block approach. So let's talk about the first aspect of the building block approach. We think about IoT in three distinct architectures: the business architecture, the technical architecture, and the market architecture. And I will go ahead and unpack each one of those architectures and what are some of the key attributes in each of those. And at the end of the day, what we will have is an integrated public sector architecture. This is really important because if we don't integrate each one of these unique architectures into a public sector architecture, we will not be able to achieve the desired result. And I'll share some examples around that as we move forward. Next, I'll talk to you about IoT readiness. So once we have this desire to do IoT in the public sector, there are things that we can do today to pave the way for a smoother adoption of IoT in the government, in education, both at the state and local and the federal level. There are some barriers to entry of IoT that I'll take you through so that you have a better understanding around what kind of baby steps in terms of a crawl, walk, run process we can move forward with. And lastly, I'll talk to you about what are some of the data challenges in the public sector. Data interoperability is one of the key challenges to lifting the public sector. At the end, I'll give some examples, and this will give you a pathway to go out and architect and develop unique applications, unique systems, and unique processes to support this unique market. So let's first talk about what are some of the IoT public sector architecture pillars. The reason I want to share these is that these important definitions are not just definitions. They are the key pillars for you to take away in terms of solution design for architecture. So first, we'll talk about security. Security ensures that there's a chain of trust, and it can be in silicon, it can be in software, but irregardless, it has to be rooted from the beginning of a system to the end of the system. And I'll be introducing edge and cloud as terminology to help you understand how security needs to be an overlay. In terms of manageability, we'll talk about how do you manage devices that are an Internet of Things thing. And the reason this is important is that once you put that thing out into the environment, you need to be able to discover it, provision it, and manage it from the edge to the cloud. The next pillar is around connectivity. Connectivity supports how we basically glue all of these pieces together. And what's unique about connectivity, especially in Internet of Things, is there's new ones that seem to be coming forward. We used to think of connectivity in terms of 3G, and now we're moving to 5G. But we have new kinds of comms, such as LoRaWAN, which allows new capabilities. We also have BLE, for instance, that has been a Bluetooth tried and true capability. And so as we start to look at all these different types of connectivities, especially in various regions, there are some unique opportunities to leverage different ones for different types of usage models. Interoperability enables applications and services to basically work across diverse platforms. Interoperability includes data, and that we'll talk a little bit more about in detail. And lastly, in terms of architecture pillars, there's analytics. And so I pulled something unique out of Gartner around advanced analytics, where we have autonomous or semi-autonomous examination of data or content using sophisticated techniques and tools, typically beyond those of the traditional business intelligence, to look at discovering deeper insights, predictions, or to generate recommendations. So if we think about these as the 5 main architecture pillars, I want to introduce you now to an example, but also some of the key terminology that I am going to be building on over the course of our time together. So in terms of digital security and surveillance, we can think about these pillars that I just discussed layering across this entire end-to-end system architecture. So if you look to the left, you'll see things such as IP cameras. If you look at something listed here as a compute node, you'll see something that we would term as a gateway. We then have a network, and then we have a cloud. And so this concept that you've been exposed to already as part of this Internet of Things discussion set today is how do you move compute to the data rather than data to compute? Or as sometimes we like to say in public sector, we want to transform or compute data into information at the earliest point of data ingestion. So when we start to look at these different architectures, and we talked a little bit when we began today about business architecture, technical architecture, and also market architecture, I wanted to share what are the makeups of these architectures and why is this important to the public sector. So when you're working on commercial deals, some of the strategies that you put in place to do design around technical architectures have a lot of flexibility. And when we say flexibility, what we mean is that there are not a lot of business constraints that you have to take into account other than the commercial activities you are doing with a company or a set of companies. When you start to work in the public sector, the aperture actually expands to be very broad, and the complexity of the business has some hidden nuances that if you walk into unaware can actually crater your ability to take solid, well thought out, excellent technical architectures that you designed for a commercial setting, and you are unable to actually implement those in a public setting. So let me share with you what some of these business architecture challenges you have to address or seek to understand when you start to collect data about what you choose to implement. So let's begin with some of the critical success indicators in the customer usage models. A lot of times in the federal and state and local environments, there are specific service level agreements that anybody working with the government or public sector entities have to meet. So those sometimes are higher or lower than a commercial environment. So one must understand what the bars are for the technology at the onset. One of the reasons this is so important in Internet of Things is that how you are going to have to meet those KPIs has an overarching reach into your architecture design. So for example, if you were going to go out and design a system for a specific part of the government, they may tell you that you must do computation at the edge in X many seconds, or you must do X, Y, and Z in a private cloud or a public cloud under this set of criteria. If you do not seek to understand those KPIs at the onset, you will run into serious challenges later on in the architecture. So similar to that, I've highlighted here procurement processes and requirements. When we are looking at doing business architectures in the public sector, there are very specific ways, and they are not standard, that contracts are put forth. So some parts of a business, if we want to use that term, that run in the public sector may have various contracts across an entire end-to-end system. One group may own data transport, one group may own cloud maintenance. And so therefore, if you're trying to put together an Internet of Things solution where you are, let's say, extending an existing architecture or driving architectures forward, this aspect around understanding who owns what is part of this environment is very, very critical. Because part of the negotiation or understanding about how you can do your design may actually be constrained through how other contracts are arranged. So it's almost like a puzzle. And this layers on to contract and cycle time, when different refreshes occur. Depending on when different technology is refreshed, there may be a direct overlay in terms of what you would like to do in terms of an interface, let's say, for developing an IoT system. So if, let's say, you're working in a smart city environment, you may struggle with how you can put a early adoption technology out into an environment when you may be working not with real-time data, but with batch data that exists because contracts will not allow an update for real-time data maybe from 5 years from the present. To look at some of these challenges, I wanted to begin to expose you to some of the business challenges, understanding who owns contracts, who works together in groups, what are some of the business and cost of ownership models, how will some of these actually move forward, and what infrastructure and products are already in the environment that I alluded to earlier in some of the examples. This piece here will create a tremendous amount of constraints on what you can do in any technical design. And so where this is important for the teams and the developers and the small businesses is that in many federal, state, and local contracts, the business architecture requirements to actually compete and win business creates opportunities and what they call set-asides for small businesses. So if you're listening in and you're a developer and you are in your garage creating some new innovation, this may be a pathway for you to work with a team who has to, let's say, have so many small businesses to actually go win a $100 to $200 million contract. So the public sector is very ripe for small businesses and developing groups to actually participate in the ecosystem of this complex contract environment. So now let's talk about the technical architecture. I went through some definitions early on. This is the place that most of us who do technology development spend a lot of time crafting our value. We talked a little bit about connectivity, a little bit about manageability, security, interoperability, and analytics. And there will be platform selections that have to be made in terms of hardware and software. This is a set of technology strategies that you will look at in terms of a technology architecture. And the last piece of the set of three architectures, we've talked about business, we've talked about technology. Now let's talk about market architecture for public sector. One of the challenges that we have with the market is the availability of technology. So when you are working in several public sector environments, some of the technology that you want to use may not be available for high volume manufacturing. So as I've listed here, highlighted in yellow, the procurement process and requirements, some of the technology at the state and local level or in the federal government level may have requirements around who can make it, meaning what countries can make it. They may have requirements to actually go through testing or meet requirements. So for example, security requirements, something called FIPS out of NIST, is required for certain applications in certain aspects of the federal government. So all these procurement processes and requirements, let's say a FedRAMP for software, have to be taken account around not only the availability of it, but also where it is in the life cycle. So sometimes in the federal government, we have to work with technology that's a couple years older than what the commercial industry would be looking at. Why? Because it takes a period of time for it to go through very specific requirements. This kind of challenge is something that needs to be taken into account when you're thinking about what's available in the market to actually use, not only for prototyping, but for volume opportunities. So the positive aspect of this is that if you do something in a federal or state environment, many times it will have a ripple impact into commercial. So some of these requirements that are difficult to address, let's say certain security requirements, some of them may ripple into commercial products later. So by participating or understanding requirements, let's say for federal government, you may actually have a jump on being able to onboard not only a more competitive product in commercial, but also a product that is ahead or advanced of other commercial products. And lastly, just like every other market challenge from an ecosystem world, infrastructure and products are already going to be existing in the environment. So your challenge when you're in public sector is sometimes working with legacy products, and can you have them interface with further back legacy products or new products. So this entire concept of market architecture is really important when you're thinking about how to approach architecture in general. So as I started to unpack the differences, one of the key important aspects for developers who are approaching the public sector is to understand your business architecture, your technical architecture, and then also your market architecture, because by working all three of these at the same time, you'll be able to understand the architecture constraints, because each one of these will have some differences. You'll be able to understand the KPIs, what are some of the critical success factors, looking at how you can abstract some of the commonalities to design for extensibility and scale, and take into account different aspects of risk, cost, and time, or time to market. So these are some of the challenges that you'll be able to pull out by doing a thorough analysis of the business architecture, the technical architecture, and the market architecture simultaneously. And at the end of the day, the best architects for public sector will have done consciously chosen trade-offs, meaning if you had to give trade-offs or had to work with regulations or had to make choices between different legacy softwares or had to pick different companies, by walking into this eyes wide open, you basically understand what are your design anchors and how can you consciously make the best decision for an integrated architecture. I spend a significant amount of time coaching people trying to work in the public sector about how to do an integrated architecture. Specifically, there are decisions that are made regularly that box commercially viable technology or technology intended for public sector out of being sold. one of the key pitfalls is trying to build this whole architecture with having no understanding of the integrated architecture. Everyone just focuses on the technology. It's a big mistake, and there are barriers that you will hit not to be able to drive your agenda or your development forward. Those people who are smart about how to do this, they actually find a slick pathway to adoption. The second piece that I see, which is not something I'll discuss today, but if people have questions, happy to answer that, is around creating modular systems, especially in IoT. So as we talked about, different people may have different parts of contracts, or there may be some kind of Lego pieces or puzzle pieces that have to get carefully fitted together. If you develop something, you want to think about how can I develop it modularly so I can reapply this innovation or my development work or my software or my analytics to other systems or projects that I'm working on. So often people are developing an entire set of code to be run in the cloud, and they haven't thought about how to break it up to maybe have some of it run on the edge as a computation. And what then happens is, as soon as someone wants to use some of this great work, they find that they can't use it. And it's not because they couldn't look at the trade-off between the cloud and the edge computation. It's because, let's just say there's a regulation or a KPI, or part of the system has to be under lock and key, or part of the system is to be maintained by somebody else. And what happens is that the solution they created is no longer applicable to an environment, and to basically try to modularize it post the original development is just too expensive. You might as well do it from scratch. So being creative about hedging your bets for modularity is a big opportunity, and it can also help drive a really good pathway forward. And the last challenge that I see is what I call being too greedy. I see sometimes where people develop this great end-to-end solution, but they are forgetting that not all parts of a solution is necessarily going to work in public sector because of how the different puzzle pieces of the contract are laid out. So for example, if you develop a fantastic edge device and a fantastic thing or a fantastic compute platform, by putting in technical hooks or business hooks to force it to go to a specific cloud, is a very bad choice. You see companies trying to monetize services as a cloud, and sometimes that can't work if, let's say, the contract requirements might say you have to go to a public cloud or a private cloud already managed and owned by a specific company, because their contract might be in a different life cycle than, let's say, the IoT solution or the technology that you're attempting to hook up in terms of end-to-end architecture. So being too greedy and trying to take too much of the pie is an area that I see more commonly happen than not. So I think part of the key takeaway for everyone listening here is specifically around keeping modularity options available, keeping interface controls available, keeping different types of APIs available, so that if somebody wants to adopt part but not all of the solution, you can easily plug and play as these public sector architecture business aspects, market aspects, as well as some of the technical aspects are a challenge to address. So now I'm going to change pace a little bit and talk to you about public sector in preparation for IoT. So when we prepare for IoT, how can we prepare for it in advance of RFIs? So RFIs are requests for information. And what commonly happens in federal or state or local is that someone will send out a request for information, and people will write in and shape some of the various areas that they would like to have an RFP, or request for proposal, address. But often the question is, let's say there's no RFI coming out if you're in the public sector, or you're sitting with a bunch of C-suite executives and they're saying, hey, what can I do now that isn't related to an RFI? And there are some common issues that need to be addressed or barriers to entry of IoT in public sector that we have an opportunity to step forward and provide recommendations for. The first is to address how we can invest in data exchange infrastructure. I'll share a little bit later about what is a data exchange, but in general, we have networks, we have security, and we have some edge and cloud systems that will not allow real-time data exchange today. Or the networks are isolated, meaning they don't talk together. This could be a legacy from how they implemented security, so they never had to patch legacy systems. So what you have is networks that are isolated. You have security challenges that are known in the existing infrastructure. And you also have some edge and cloud systems that today are in existence in various piecemeal, but don't necessarily have a common connectivity infrastructure. So by investing in doing an enterprise review of your systems and by seeking to understand how you can create pathways and connectivity and overall systems to support real-time data exchange or near real-time data exchange, those are concrete things that can be done irregardless of what things or what gateways you may actually look at integrating. A great example is I consulted with a group that had all these wonderful sensors set up. They were looking at how to do some real-time data exchange, and they had two problems that were never addressed. It could have been addressed years ago. One was they had a network that didn't connect to their network topology for the rest of the company. And so that took several months of negotiation because that network was owned by a third party. No one ever looked at the topology. So we had to figure out ways to move that data across networks. Another example was that once we got through that, there were some systems that were so old and fragile that were never migrated from about 20 years ago that the batch data could only be run in the middle of the night a couple times a month. And so until these problems or barriers got removed, we could not actually move forward and implement the IoT solution that was desired despite the amount of investment. So just as an example, this is a place that if we're working as developers or starting to work with people, these are some of the opportunities to start talking to folks about. The other piece is the data interoperability side. So all this different data comes out of different sets of systems. So you've got Internet of Things collecting information. You have existing systems that are funneling information across environments. And so you ask yourself, how can we manage all of these different highly interactive systems that as soon as you hook all this data up together and you start to actually drive computations, as soon as one person changes one part of the system, the whole aspect of the computations that you just put together may start to go awry. So there are companies today that specialize in data transformation, and that's a services and it's in a business itself. But the key question is, how can you start as a developer to identify standards that you are starting to program with that help you hook up into different systems? How are you today starting to look at digital objects that basically are streams of metadata that characterize your environment? And how are you thinking about data as a whole? Meaning you've got data transformation challenges. How would you manage and maintain that from a cost of ownership? You've got data ownership. Who owns what parts of the data? And how can that data actually be pulled together and abstracted and or decomposed to basically start a comparison process between apples to apples instead of maybe having an orange and an apple come in? And then how would you start thinking about objects and architectures? The more different things that are put together, if you're putting together an end-to-end system, would you create a metadata stream that might have the first data type actually coded to say, hey, I'm going to use a 1 if this is a hearing aid. I'm going to use a 2 if this is a light bulb. I'm going to use a 3 if it's a smartphone data stream. And so you start to look at how do you want to think about all of these different architectures and objects to meet your objective. So these are plans and or strategies you can start partnering with others. You can start thinking about for yourselves as you start to drive some of the development. So as we talked about this beyond RFIs, I want to introduce this concept around marketplace platforms for data, or what is termed today data exchange. And the reason that I want to talk about data exchange is I briefly discussed the data interoperability, the data transformation, the data ownership, and some of the digital objects. But the reality is that data exchange is a way to exchange data between multiple parties. Platforms are being developed. NIST, National Institutes of Standards and Technology, is actually in the beginning of 2018 putting together teams to start looking at how data exchange is going to start happening across a wide variety of fields. And one of the key things that I thought about when I was asked to speak to this group was, do developers have a good understanding of data interoperability requirements? And do they understand the concept of data exchange and open requirements? So if we start thinking about all these different architectures and some of the key takeaways, one of the biggest challenges that you want to address is how will your pieces of systems or things, or let's say you're doing a distributed computation, how are they going to fit into a broad data exchange or a platform? So if you think about something like a smart city, you may have a common platform that has to integrate all different types of things. How would that data exchange work, and what would be the inputs and outputs of that large-scale system, and how would those requirements map onto it? So this is a really busy slide, but I wanted to introduce this to you in terms of thinking about data. People are saying data is the new oil, right? Think about data in terms of a marketplace for information. So in terms of Internet of Things, you would have a collection platform. That would be where you would be collecting data. You would have a transaction platform. You would have some kind of data bank where data would interact with other types of data from a variety of different environments. You would have different search engines to go and find data. And you would also have intelligent stores where you could actually have analytics as a service. And the reason that this diagram is really nice is that it shows from a developer point of view, there are a variety of opportunities from an Internet of Things environment where you could play a role in participating in the data and IoT ecosystem. So if you think about collection platforms, that's the heart of IoT's edge. And if you move to the right across this diagram, if you look to the right, you're going to think about that in terms of the cloud. So one of the ways that this is actually going to work is we've talked a little bit about digital object identifiers, some aspects of real-time data. So how would the timing work in between different systems? And then what would be some of the context or the semantics by which data was understood? So from a development perspective, how you choose to characterize data collected from an Internet of Things device and how it would actually move across a marketplace for data creates an opportunity for tremendous innovation. And we often talk about IoT in terms of a hardware and software platform, but in terms of a marketplace for data platform, the collection aspect is where all of the IoT information begins. So let me give an example of this. So I started with an example around Internet of Things and talked a little bit about an edge in a cloud. And so if we kind of go back, I used a camera as an example. So if you look at a collection platform, an example of a collection platform might be a camera. So this is what I showed from the earlier example, where a camera would be the collection platform. You would have some type of computation. You could have the computation actually on a camera. You could have some intelligence there. You could have a further aggregator and compute vehicle be a compute node. You would have a network, and then you would have some type of cloud. And so here in the public sector, we have private clouds and public clouds and hybrid clouds, all kinds of clouds. And one of the important aspects of this diagram is that at different points along the way in a data economy, you'll be able to have different levels of computation as well as different development opportunities to participate in this ecosystem. So wanted to share with you and start opening your imagination to how you could start innovating across these various areas. So if we look at an example around vision, so since we shared a camera, I'll share a little bit about the visioning aspect. If you were to have on a camera, an IoT wearable camera, and you were to look at having sensors and processing, and part of the opportunity for a development platform might be in basically ingesting some of the computation from the lens of the camera, and then looking at how to transform that and compute that into information. You may be sending then information onto, let's say, a mobile or network device. Let's say this represents your gateway, and you're potentially bringing in other sensors, maybe from other parts of an IoT system, and you're starting to fuse data together. And then let's just say you're sending it out on the network. So if you think about some different local processing on a wearable, you can think about maybe some distributed processing on a smartphone, maybe as I talked about, bringing in some other image and sensors, and then sending it over for some more processing in the cloud. You can think about using this as an example of something I talked about earlier, which is how you would be able to create modular aspects of processing or modular aspects of developing. And then you can look at satisfying specific power and latency requirements. For example, one of the use cases that I work on for the federal government is how do we process video at the edge in under X many seconds? And so one of the use cases I'll share in terms of a good story versus a not so good story is I saw one partner actually go through and create a distributed computation and used inferencing from the cloud and did video image analysis right on the camera at the edge. And it was very, very successful, and they were able to make the latency and power requirements work for a federal agency. Where I saw it not work well is where we had a company go in and spend a tremendous amount of time developing a very, very wonderful algorithm that was optimized to run in the cloud. However, because of the environment and the requirements for specific computations, that technology did not actually translate back to meet the distribution requirements, meaning there was certain requirements that had to be met at edge processing because the pipe, the wireless communication that the entire building was quote unquote fixed in, remember fixed constraints from a business architecture, did not actually meet what the technical architecture requirements were, so therefore the KPIs couldn't be successful. So wanted to just kind of share that these are the kinds of ideas when you start looking at all of these technology trade-offs, you want to start looking at this across the board, but also want to make sure that I'm layering on the fact that this data transformation or some of these digital objects or how you structure this, that is an important factor on top of all these pieces. So how you play as a developer into all these different pieces and parts are highly relevant. So just to kind of share and just to kind of broaden us back up to a higher level is we talked a little bit about the cameras in some areas, but if you start to think about the family of things, how many different types of intelligent vision, edge sensing capabilities there are. If you look around today, just in this small set of systems that are named, you've got robots and drones and surveillance systems, and you've got things in the home, and you've got wearables, all kinds. And so if you start to think about all the different kinds of development opportunities you would have across all of these various areas, and you start to then now think about how much data in different types of data, in different types of things, in different metadata streams, and some of the complexities of building systems and how to interface back, I'm very hopeful that some of the concepts we briefly talked about in terms of business architecture and technical architecture, marketing architecture can help you start to think about or inspire you in terms of innovative thoughts. So I want to leave you today with one key takeaway. The complexities of an IoT integrated architecture design really need to be understood by the development community to successfully participate in the public sector ecosystem. It is absolutely critical that thought be put into how all of these different pieces fit together so that before you start doing a development project, you spend a little bit of time doing an architectural set of trade-offs, and that you are able to then think about how can I best create a development set of deliverables to bring to market, to partner in the public sector space, if that's the market you're aiming for, to actually have an adoption. And I think as I talk to different companies, different people, I talk to federal, I talk to state and local folks, these are some of the opportunities that sit ahead of everybody in terms of thought leadership. There is a void today in thought leadership and how to do these architectural designs right. By merely thinking through this, I believe that every developer can have a leg up on folks who are not thinking about some of the complexities as they move forward for public sector.